All right, let's look at the most commonly missed questions from the first part of this practice AP test. So number one said, let f be the function given by f of x. Which of the following is the x-coordinate of the point of inflection on the graph of f? All right, so point of inflection, our first instinct should be to go to second derivative and check for a sign change. So I'm going to start with f prime of x. We've got a product rule here. So I have first d second, and d second has a chain rule in it, plus second d first, which is just a 1. All right, clean that up, and I'm at negative x e to the negative x plus e to the negative x, and that's f prime of x. All right, then we're going to go to the second derivative. So the first piece of this, we have a product rule. So first d second plus second d first, and then the derivative of that last piece there is going to be an e to the negative x times a negative 1. All right, so if I start cleaning that up, I get x e to the negative x, and then I'm going to have a minus e to the negative x minus e to the negative x, so minus 2e to the negative x. All right, so there's our second derivative. Now we take our second derivative, set it equal to 0. I'm going to factor an e to the negative x out. That leaves me with an x minus 2. All right, so I have e to the negative x equals 0, which is never true. X minus 2 equals 0, which is true when x equals 2. All right, so our instinct here would be automatically inflection point at 2, but then we've got to remember we have to do a sign test. All right, the answer choices on this one really gives us the answer that it's going to be 2 at this point, but this is really where we get caught up on a lot of problems. We've got to do a sign test. So at 2, if I test to the left, so like 1, I get positive and negative, so that's going to be negative. If I take a value out here to the right, that's going to be like 3. I get positive and positive, so there is a sign change. All right, so our correct answer is D. All right, correct answer on number 1 is D. All right, pushing to number 5, this is another commonly missed one. So this asks about differentiability. So there's two components to differentiability. It has to be continuous, and the limit of the derivative from the left and the right have to be the same. All right, so first thing I'm going to do is set up for continuous. Continuous would say when I plug e in, the point they're concerned about, all right, the left and the right have to be equal. So 1 plus ln of e needs to equal ae minus b. All right, ln of e is 1, so I get 2 on this side, equals ae minus b. I'm going to move around the things a little bit, so b equals ae minus 2. All right, so we're probably going to need to come back to this because it asked me for the b value. All right, so I'm going to go to the second component, which is that the derivative from the left and the right are equal. So the derivative of the top of this is just 1 over x. The derivative of the bottom of this is just a. All right, and I need these to be equal at e. So 1 over e equals a. All right, so now I'm going to take this a value and I'm going to bring it back here to plug it in to find b. So b equals 1 over e times e minus 2. All right, that's going to be a 1 minus 2, which is a negative 1. All right, so again, I've got that b value has to be negative 1 for this to meet both criteria of being differentiable. All right, so it has to be equal from the left and the right on the function and on the derivative. All right, pushing to the next commonly missed one. We're at 8. 8 is really a stretch problem. First thing I'm going to do is I'm not going to worry about the limit, but I'm going to expand out the inside. All right, so if I expand out the inside, if I plug 0 in, I get, let's see, that would be x to the 0, so that's a 1, over 0 factorial, so I really get a 1. Plus, if I plug a 1 in, I get x over 1 factorial. If I plug a 2 in, x squared over 2 factorial. 3 in, x cubed over 3 factorial, and so on. Now, this is a stretch one because what really we need to know to be able to do that is that that's the power series for e to the x. We built that from the ground up using a Taylor polynomial, but again, we never got to the point where we're really like forced into having it memorized and looking at intervals of convergence, radius convergence. So I think this is right on the cusp of what they could ask. So I'm going to do a substitution, and I'm going to say the limit as x goes to 1 of e to the x, because that's the power series that's equivalent to it. So if I evaluate that, I get e to the first, which is just e, and my correct answer is D. All right. So again, 8 is right on the cusp, likely not something that would be on this test. What I could see them more likely doing is asking you to write a Taylor or Maclaurin for e, building it from the ground up, or for another function. All right, moving on to the next commonly missed one. This is a fundamental theorem of calculus problem. All right, we have f of x equals the integral from 0 to ln of x, e to the negative t dt. All right, so if I want to find f prime of x, I start by plugging in the upper bound, so e to the negative ln of x. All right, and then I have to multiply by the derivative of the upper bound because it's not just an x. All right, so at this point I'm at I'm going to move that exponent up, so e to the ln of x to the negative 1 over an x. All right, now using algebra 2, e to the ln cancels out, so I really have 1 over x over x. All right, because e to the negative 1 is 1 over x, and then the e to the ln cancels. So if we have e to the ln of a, that's just a. So e to the ln of x to the negative 1 is just x to the negative 1. All right, so it's a simplification using the fact that e to the x and ln of x are inverses. Now, if I multiply by the reciprocal to clean that up, that's 1 over x squared. At this point, we would have everything we need, so we go back, and our correct answer is C. All right, for the derivative. Now, moving on to the next commonly missed one. I believe we have one more. Yep, number 15. All right, so number 15, it asks for f prime of pi over 6, and we have 1 minus cosine x over 1 plus cosine x, and it's an ln. So first thing when I glance at this, I do initially have some thoughts that we might be able to do like a conjugate, but then I hopefully think back to my algebra 2 days and think about rules of logarithms, right? Because I have f of x, and I'm not doing a derivative yet, but I can change this to ln of 1 minus cosine x minus ln of 1 plus cosine x. Now I've got much easier derivatives to take, so when I do f prime of x, 1 over 1 minus cosine x times the derivative of the inside, derivative of 1 is 0, derivative of cosine is negative sine, so this would be positive sine x. All right, minus 1 over 1 plus cosine x, and this one would be a negative sine x. All right, so I clean that up a little bit. I've got sine x over 1 minus cosine x, minus negative, so plus sine x over 1 plus cosine x. Now this is at pi over 6, so if I think unit circle for a second, it's the lower one, so that's going to be over root 3 over 2 and up 1/2. All right, so I start plugging in what I know, so sine x, that would be the y value, so I have 1/2 over 1 minus root 3 over 2. All right, and then I've got plus sine x, so 1/2 over 1 plus root 3 over 2. All right, so I need to get a common denominator, but first thing I'm going to do is I'm going to tidy up just a little bit. So I'm going to send a 2 through everything, top and bottom of this one, so I get 1 over 2 minus root 3. And I'm going to do the same thing in this one, so I get 1 over 2 plus root 3. All right, so the first one I'm going to multiply top and bottom by a 2 plus root 3. So I get 2 plus root 3 over 4 minus 3. All right, if we do our difference of 2 squares. And then on the second one, I get a 2 minus root 3 top and bottom. So that's going to give me 4 minus 3 in the bottom. All right, so the bottom's going to be a 1, so I just add the tops. 2 plus 2 is 4. Root 3 minus root 3 is 0, so I just get a 4 there. All right, so my correct answer on this one would be positive 4, which is E. All right, so those were the most missed problems from this multiple choice set. I hope that was a helpful explanation. If you have any other questions, don't hesitate to reach out via email or during our Q&A session tomorrow. Thanks.